So we're going to take a look at slide 5 of Chem 2B together. We're going to look at this equation on the left. Notice that it is talking about gas combustion in cars. So let's do a quick reminder about what are the different numbers that we see so we can come back to them and remind ourselves what is going on, right? So numbers in front, when you see them in front of a molecule or a compound, right, that tells us the coefficient, and that means the number of molecules present or compounds present, okay? So in this case, that 2 tells us that there are 2 C8H18s, and then there's a 25 that tells us there are 25 oxygen or O2 molecules. And when those combine to react, right, we have this arrow that tells us that we are reacting. Then we form 16 molecules or moles of CO2 and 18 of H2O. Okay, so that's the first piece of information. The second piece of information are all these little numbers, right? So all these little numbers, those are called subscripts. And subscripts tell us how many of each element are present in the molecule itself. Okay, so that's going to be the number of elements in a molecule. Okay, so for C8H18 that we've been looking at, right, that means that there are 8 carbons and 18 hydrogen. Okay, and then we have 25, so remember that's our coefficient of O2, and that 2 tells us that this molecule has 2 oxygens in it. Okay, so let's go ahead and look through these questions real quick together. Right, the first one, how many moles of C8H18 are needed for the reaction? So this reaction is balanced. We're going to talk about what that means in later slides. But as we look at it, it's asking us how many moles are needed. So we actually need 2 moles for this reaction as written. What that means is that if we think about recipes, we're told we have 2 cups or 16 tablespoons or 4 ounces. That unit of tablespoons or ounces or cups or liters, we're all going to simplify that down, that anytime you see a number in a reaction in front, that coefficient, that means that it's the number of moles. Okay, so it's even easier than a recipe, because a recipe has all sorts of units, but a reaction only ever uses moles. So that's moles, this is moles, right, 25, this is moles, 16, and 18 moles. Okay, so very easy. So that means that for C8H18 we have 2 moles, so we're going to put a 2 there. We're going to skip around just a little bit so we can make sure we answer all these questions, and then we'll kind of head back to look at the other ones. So what is the coefficient for CO2? So here is CO2. The coefficient is the number in front, so that's going to be 16. And then what is the coefficient for O2? Here is O2, and there is the coefficient of 25. All right, so now let's tackle these little challenging more questions, right? We have, if you have 50 moles of O2, so here's our O2 again, remember? How many moles of H2O would we make? So the question is if I have 50 of those, what am I going to do to make the number of water? So what we're going to do is we are going to set up our problem. We're going to say we have 50 moles of O2, right, from the problem, which is what we have. Remember this formula. And we're going to set up our bar. And then in our bar, we are going to put what our reaction is telling us. So I started with moles of O2, so I'm going to put moles of O2 on the bottom. And then our problem tells us that we need moles of H2O. So our need goes on top, right? So the same thing you've already done. And then we're going to use the reaction to actually tell us the numbers. So moles of O2, here's moles of O2. There's a 25 in front. H2O, there's an 18 in front. So I'm going to put an 18 in front. And then I'm just going to solve this. Okay? So when I solve it, the moles of O2 are going to cancel. And I'm going to get 50 times 18 divided by 25, which you can either plug this whole thing in the calculator or you can simplify it because 50 and 25 have a common factor of 25. So it becomes 1 and that becomes 2. So 2 times 18 is 36. So that means we would make 36 moles of H2O. So we're going to put, we're going to put 36 here. And the last one is the mole ratio for H2O to CO2. Okay, so H2O from our reaction is 18 and our CO2 is 16, but we need to simplify this down. So common factor between 18 and 16 is at least 2. We could at least divide it by 2. So we're going to divide both sides by 2. Let's see if that makes it small enough. So then what do we get? We get 18 divided by 2 is 9, and we get 16 divided by 2 is 8. We cannot simplify that any further. There's no common factor between 9 and 8. So we are going to go ahead and put 9 to 8 right there. Okay, and notice now we have solved all of these options. Nice job.